We've spotted water, methane, and strange patterns on Mars before. Yet this new discovery by NASA flips the search upside down. Microbes may have once thrived there. Mars has always been the prime candidate in our search for alien life. For decades, missions uncovered strange clues, but never the proof we needed. The Viking landers in 1976 detected unusual reactions in Martian soil, but later scientists traced them to chemicals, not microbes. Later, Curiosity picked up methane spikes that rose at night and vanished by day. Mysterious, but never confirmed. Seasonal streaks on slopes once looked like running water, but fresh data showed otherwise. Every clue felt close, then slipped away. Now, Perseverance has changed the story. The rover drilled into a slab of rock in Jezero Crater, a place that once held a massive lake. This ancient basin is thought to have collected water for millions of years, providing a stable environment where life, if it ever arose, could thrive. The slab that Perseverance targeted stood out the moment cameras caught it. Its surface was dotted with strange markings the team nicknamed leopard spots and poppy seeds. These marks were not only visually unusual, they suggested processes far more complex than simple erosion. For trained scientists, they were not random scratches. They looked like possible signatures of life locked in mud and mineral veins. The excitement grew because Jezero had long been chosen for its ancient river delta, a feature on Earth often rich with fossils. By finding such textures here, the mission tapped into that very hope. Scientists immediately began imagining the conditions that could have created these features: still waters, muddy sediments, minerals settling layer by layer, and possibly microbial activity shaping the patterns. Every tool on board was put to work, from high-resolution cameras to spectrometers, building a complete picture of this extraordinary rock. Pixel mapped the chemical elements. Sherlock used its lasers to scan for minerals and organics. The results were beyond expectation. The rock carried organic molecules, carbon compounds that formed the base of life. It held sulfur, phosphorus, iron, and two minerals rarely seen without biology: vivianite and greigite. On Earth, these appear where microbes interact with their environment, feeding and decaying. They are the residue of living chemistry. Think of it like this. Imagine stumbling across a ring of stones, ashes, and scraps of food in the woods. Even if no campers are there, you know a fire once burned. That is what Perseverance may have uncovered, the fingerprints of ancient life preserved in Martian stone. Yet NASA remains careful. They rely on a confidence of life detection scale, ranked from 1 to 7. This sits at level 3, which means there are suggestive hints, but not the certainty of proof. The classification reminds scientists and the public to keep expectations realistic while still acknowledging the weight of the evidence. The rock shows strong signals that could be linked to life, but alternative explanations must be tested one by one. Could extreme heat have formed these minerals? No. Vivianite would have burned away under high temperatures, and the patterns we see would never have survived such stress. Could acid water have created them? Doubtful, because olivine inside the same rock survived intact, and acid would have erased it completely. Could a slow chemical reaction without biology have mimicked the results? In theory, yes, but the conditions inside Jezero Crater don't line up with that model. Every alternative explanation is pushed forward, checked against the data, and then falls apart under closer review. The more the theories fail, the more the biological path gains weight. This careful process might frustrate those hoping for bold headlines, but it ensures that when scientists finally say yes, they can defend it beyond doubt. It also shows how science moves, step by step, removing uncertainty until the most likely story is the one that remains. Each layer of caution adds credibility to the discovery, reminding us that extraordinary evidence takes time to build. What remains is the biological route. Microbes in Jezero's mud lake may have used iron and sulfur as energy, leaving behind the spots we see today. For the first time, one Martian rock shows all three conditions of life together: water, organics, and energy. That trio defines what life needs anywhere. To grasp the weight of this find, remember the history. Vikings' fizzing soil stirred hope, only to disappoint. Curiosity's methane spikes fired imaginations, only to confuse. This discovery is different. Its chemical markers line up too closely with life's fingerprints. Many researchers call it the strongest evidence so far. The meaning is enormous. If life began both on Earth and Mars, it suggests life is not rare. It implies biology is a natural outcome when the right conditions appear. Picture microbes in Martian lakes, while early oceans on Earth nurtured our ancestors. Life would no longer be a cosmic accident, but a rule. Perseverance has taken us further than any mission before. Scientists have pored over the data for months, stress testing every explanation. Independent experts joined the review, searching for flaws. None found a stronger alternative. Still, NASA chooses caution. They know Carl Sagan's warning: extraordinary claims demand extraordinary evidence. Until samples come back to Earth, the agency avoids definitive language. But excitement within the scientific community grows louder each week. The challenge is clear: perseverance cannot prove life alone. Its tools give hints, not certainty. For that, the rock must return to Earth. The rover has drilled a core, sealed it in a tube, and stored it safely. That sample, nicknamed Sapphire Canyon, may be the most valuable piece of rock ever collected beyond Earth. The plan is Mars sample return. It requires 3 linked missions. One rover will gather tubes, a rocket will launch them into orbit, and another spacecraft will bring them to Earth. It is the most complex relay ever planned in space exploration, and right now, it stands on shaky ground. Budget cuts and political debates threaten the mission. Delay or cancellation could leave the answer locked on Mars for decades more. Humanity may be holding the answer to the oldest question: are we alone? Yet money could stop us from finding out. That thought weighs heavy. If we fail to act, it will mark a turning point where history slipped through our fingers. Inside this rock lies a story. The spots are filled with iron and sulfur, signs of metabolism. On Earth, bacteria in swamps and riverbeds trade electrons with minerals to survive. The Mars rock shows the same marks. Vivianite appears in low-oxygen waters, where microbes thrive on decay. Greigite forms as a byproduct of bacterial activity in sediments. Together, they make a chemical case that screams life. Skeptics still push back. Could geology do this alone? Maybe, but the conditions needed, high heat or strong acid, don't match Jezero's calm waters. That leaves biology as the stronger fit, not final, but compelling. A puzzle where the pieces align too neatly to ignore. This isn't the only strange clue Mars has shown us. Curiosity measured methane bursts that defied explanation, spiking unpredictably as if something underground was breathing. Opportunity once found a donut-shaped rock with odd chemistry that seemed to appear from nowhere, baffling mission control. Later, orbiters tracked seasonal streaks across slopes that looked like flowing water, only for the data to challenge that idea. Mars keeps whispering secrets, handing out hints and puzzles, then pulling them back before we can be sure. This latest find, however, feels louder and more complete than any before. It gathers many signs into one clear case, a chorus of clues rather than a single note. It reminds us that Mars is not a dead world of dust alone, but a place with layers of history still waiting to be uncovered. Each discovery builds pressure. Each mystery raises the stakes until the evidence is too heavy to ignore. Imagine scientists holding this sample in a lab, slicing it thin, examining it under electron microscopes. That could end the debate once and for all. That is why Mars sample return isn't just another mission. It's the key to humanity's greatest answer. Are we alone in the universe? If microbes thrived there, it reshapes our place in the cosmos. Earth would not be unique. Life would be a common thread stretching across space. That thought is humbling and powerful. Arthur C. Clarke once said, "Two possibilities exist. Either we are alone or we are not. Both are terrifying." This discovery leans toward the second. Life may not be rare. It may be everywhere. Think of icy moons with hidden oceans, or planets orbiting faint red dwarfs. If Mars lived once, other worlds may live now. NASA's careful words cannot hide the weight of the evidence. Mars may be silent today, but its stones carry whispers of life. We stand closer than ever to knowing the truth. The story is unfinished, but the spark is here. Humanity now knows what to seek, what to test, and what matters most. The coming years will decide if we confirm alien life in our lifetime or leave the question unanswered. Perseverance has done all it can. The rest is up to us. If you want more hidden updates on space discoveries that reshape how we see the universe, subscribe so you don't miss the next story.